In the name of Allah, the Compassionate and the Merciful. Hello guys, I am Salar Delavar Qashqai, and in today's video we're going to model the soil foundation interactions analysis with finite difference and finite elements method. The finite difference method is an approximate method for solving differential equations, and it's very applicable for solving in structural and different differential equations approximated method. In this example, we are going to define the rectangular foundations and then applying the central force at the center of these foundations, and then defining the soil stiffness, and with these equations, guys, we're going to solve the finite difference method, and also we're going to model this structure with OpenSees as a finite element method. So we're going to compare this approximate and exact method and seeing the result. So if we write the codes and then running the analysis, you see the foundation displacement of each method is going to be calculated and shown. So finite difference method has this shape of displacement, and also finite element with some spring under the foundations. It's going to be run in OpenSees, and you see the displacement and also base reactions of the finite difference method and also finite elements method. And at the end, we're going to see the difference of these two methods result. So you see, in some cases in the center of these foundations, so difference is very high, and also you see for also reactions, this difference is very high, near minus 96%. So it shows that we can use finite difference for very simple modeling as a linear or elastic method. If we want to indicate the nonlinearity in our analysis, so we must not use this finite difference method. So let's see the codes. You see, guys, in here I developed these codes as a finite difference and finite elements method. So we're going to define the elastic moduli of elasticity of the foundations, height and width of the foundations, length of the foundations, and also stiffness of the soil. So it is not the exact values, guys. I just want to show you how can we model this two kind of analysis, and you can change it with your own data. The codes are available in my GitHub, and you can change it with your own parameters, and also applying the minus 1 million Newton as applied the center of the foundations forces, and also definition of the Poisson ratios, and also density of the foundations as a material properties, and also moment inertia of the foundations, and also definition of the coordinate of each node. So you see, guys, along the x and y direction, we defined some nodes for calculating the finite difference and also finite elements method by meshing the areas. And also you see, guys, in finite difference method, we're going to define the parameters in A matrix, and then defining B as a boundary conditions of the loading vector, and also in here we are going to define the stiffness of these foundations with springs, and also you see in here we are going to define the soil springs, and also in here we are going to define the boundary conditions of the modeling, and also we are going to run the analysis as a linear analysis, and then outputting the reactions. So in here we're going to output the displacement, and then outputting the reactions of the finite difference method. So in first example we're going to output these two outputted as a displacement and base reactions data. And also I developed the finite elements method with OpenSees as a 3-dimensional modeling of this analysis, and in here I defined two kind of materials. You can change it with your own data. So I used no tension soil, and you can change it, for example active this and then run it, no difference. But in some cases when the soil is going to be tension, this method is very efficient. This method is very efficient, and you must use this concept for running and getting the exact solutions. And in here we're going to define the nodes and coordinates, and also defining the boundary conditions of this OpenSees file, defining the soil spring in here as a zero length element in vertical directions, and also defining the elastic isometric for definition of the foundations, and also as a materials, and also shell as an element, and also running the analysis as a static analysis and applying the force at the center of the foundations. And let's see, yes, in here we're going to run the static analysis just one time, and then outputting the displacement and reactions. And in each node we're going to output the displacement and reactions, and then plotting the data. So after running the code, the OpenSees file's outputted data is going to be shown. So you see guys, after running this OpenSees file, we're going to output the foundation displacement, finite element method with this graph, and also soil reactions force with finite element method with this shape. And we can see the difference between the finite difference and finite elements method. So it shows that in some cases the finite difference is very applicable, but in the nonlinearity conditions this finite difference method is not applicable and efficient for solving the complex differential equations and also models. So these videos which I prepared just for educational purpose, please have a comment or even email me to tell me know about this kind of modeling. God bless you guys. Bye.